I'm doing derivatives day 3. I'm doing this right after I did derivatives day 2. I'm trying to get all of these videos done in one day. Okay, derivatives day 3. Super important concepts for you to understand moving forward into Calc 1 or AP Calculus next year. And we're going to be doing derivatives of products and quotients and then something called the chain rule. Make sure you have your notes in front of you. Your filled in notes, your blank notes, or a blank sheet of paper with the filled in notes. Stop this video a lot as I'm going through it to try to understand what's going on here. Okay, so the first Roman numeral number 1 is your product rule. And if you have a function that's two functions getting multiplied together, u of x would be the first one, v of x would be the second one, then finding the first derivative, you keep the first function, you multiply it by the derivative of the second, and then you add on to that the second function times the derivative of the first. So here's example number 1, and we're using a product rule. So our original function, f of x, is equal to 2x plus 3 times 3x squared. Now this one, you could certainly just distribute the 3x squared and take the derivative of each piece, and that might not be a bad idea to do first, just to make sure that you understand that this really works. But using the product rule, the first derivative, f prime of x, we're going to say that this is our first function, and this is our second function. That might be helpful for you to kind of identify it. And using the product rule for the first derivative, you take the first function, which is 2x plus 3, and you multiply that by the derivative of the second function. The derivative of 3x squared is 6x. Then you add on the second function, which is 3x squared, and you have to multiply that by the derivative of this first function. Okay, the derivative of 2x is just a 2. Remember, the derivative of the constant 3 is 0. So make sure you understand what I did so far. Here's the first function times the derivative of the second plus the second function times the derivative of the first. Multiply this stuff together, and then we're going to combine to get our first derivative. So f prime of x will be equal to 12x squared plus 18x plus 6x squared. Combine like terms. The first derivative of this function using your product rule is 18x squared plus 18x. Okay, that was a real easy first example just to get you understanding by the derivative of the first times the second. Now the second example is a lot more involved. Here's example number 2. All right, so our original function, y equals the square root of x plus 3 times x squared minus 5. Whoops, x squared minus 5x. Okay, I'm just going to rewrite this. Instead of with that radical sign with an exponent, remember that the square root can be written as anything to the 1/2 power. So my original function is equal to x raised to the 1/2 power plus 3 times x squared minus 5x. Now, on this function again, you could use FOIL and then take the derivative of each piece, but I want you to practice it using the product rule. Okay, so y prime, our first derivative, is equal to, here's our first function, x to the 1/2 plus 3, and our second function is x squared minus 5x. All right, so it's the first function, x to the 1/2 plus 3, times the derivative of the second function. The derivative of this second function is 2x minus 5. And then you add on plus the second function, which is x squared minus 5x, times the derivative of this first function, and this will be 1/2 x raised to the negative 1/2. Remember, you multiply the 1/2 times 1 and you subtract 1 from the exponent. So what we've done so far, here is our first function. The 2x minus 5 is the derivative of the second function, plus the x squared minus 5 is our second function, and this 1/2 x to the negative 1/2 is the derivative of the first function. Now you have to multiply all of this together, and then you're going to combine like terms. So our first derivative, remember that when you're multiplying, we're going to use FOIL here on these two binomials. So the coefficient of this times 2 is going to have a coefficient of 2. And remember, when you're multiplying x to the 1/2 times x to the first, you add your exponents. And when you add your exponents, you're going to x raised to the 3/2 power. Then your outside with FOIL will be negative 5x raised to the 1/2. Your inside with FOIL is going to be plus 6x. And then last times last is negative 15. So that's multiplying those two binomials together using FOIL. I'm going to multiply these two things together. I have to distribute 1/2 x to the negative 1/2 to both of these. So it'll be plus 1 times 1/2 is 1/2. Add your exponents. If you have 2 plus a negative 1/2, that adds up to be 3/2. And then negative 5x times 1/2 x to the negative 1/2 power is going to be negative 5/2. Add your exponents. This is a 1 minus 1/2. This will be to the 1/2 power. Combine like terms. So this 2x raised to the 3/2 power and this 1/2 x raised to the 3/2 power, you add those together. So the first derivative, 2 plus 1/2 is 5/2 x raised to the 3/2 power. Then I'm going to combine this negative 5x to the 1/2 minus 5, oh, this should be a 2, 5/2, it should be a 2, 5/2 x to the 1/2 power. I wrote that completely wrong. Let me go back and fix this. Negative 5x times x, 1/2 x to the 1/2 power. Negative 5 times 1/2 is 5/2. You got to keep that variable of x in there, and when you add the exponent of 1 plus negative 1/2, you get 1/2. So now when I add this negative 10/2 minus 5/2 is negative 15 over 2 x to the 1/2 power. I have a plus 6x minus 15. So all of this is my first derivative. Lovely. Okay, then the next thing is the quotient rule. So you use the quotient rule when you have a function that's a fraction. And the way you find the derivative of quotient is it's the derivative of the numerator times the denominator, and then there's a subtraction, the derivative of the denominator times the numerator divided by the denominator squared. Okay, and again, if you follow my notes, I have that written out here in words. I've got it in symbols and in words. I think it's easier to understand in words. All right, let's go through these two examples. Example number 3. We are going to find the first derivative of y equals 2x minus 1 over 4x plus 3. Okay, so the 2x minus 1 is the numerator, 4x minus 3 is the denominator. The way you find the first derivative, y prime, you start with the derivative of the numerator. The derivative of 2x minus 1 is just 2. You multiply that by the denominator, which is 4x plus 3. This formula has a subtraction in it. Then you use the derivative of the denominator. The derivative of the denominator is 4. Multiply that by the numerator, 2x minus 1, divided by your denominator, 4x minus 3 squared. Okay, now we don't have to expand the denominator. We can just leave it as 4x minus 3 squared, but you do have to clean up the numerator. So your first derivative, distribute the 2, is 8x plus 6. Distribute a negative 4 minus 8x plus 4. And then the denominator is 4x minus 3 quantity squared. So your first derivative, those 8x's happen to cancel, is equal to 10 divided by 4x minus 3 quantity squared. You do have to include that in your derivative, x cannot equal 3/4 because that would give you a 0 in your denominator. I don't think this is real hard to follow. Let's try another one. Let's do example number 4, which is a quotient rule. And remember, please stop the video and, like, stop it, write something down, understand it, stop it, write something down, understand it. Okay, here's example number 4. Our original function, f of x is equal to x squared minus 2x over x plus 1. Okay, so we are going to find the first derivative of this function. Because it's a fraction, we have to use the quotient rule. So the quotient rule, I'm going to use the other notation, dy dx. Remember, f prime of x, y prime, and dy dx, I'll mean the first derivative. You start with the derivative of the numerator. The derivative of the numerator is going to be 2x minus 2. You multiply that by the denominator, x plus 1. There's subtraction in this formula. Then you use the derivative of the denominator. The derivative of x plus 1 is 1 times the numerator, x squared minus 2x, divided by the denominator squared. Okay, so your first derivative, use FOIL here, so you'll get 2x squared. This is a negative 2x and a positive 2x. Those are going to cancel out. I'm going to do every step. Plus 2x minus 2x, and then last times last is negative 2. When you distribute a negative 1 to x squared minus 2x, you'll get negative x squared plus 2x divided by the denominator squared. Combine like terms in the numerator. The first derivative, dy dx. 2x squared minus x squared is just x squared. These cancel, but there's another positive 2x over here, minus 2 divided by x plus 1 squared. And in our first derivative, x cannot equal a negative 1. You don't have to expand the denominator, and you don't have to factor the numerator of the factors. All right, then the last part of these notes is called the chain rule. And you use the chain rule when you're taking the derivative of some polynomial function raised to a power. Now, say you have the polynomial function 2x minus 7, and it's raised to the 7th power. You are more than welcome to go back to binomial expansion and Pascal's triangle and expand that huge binomial and then take the derivative of each piece of it. But that's a really hard way to do it. So learning the chain rule makes a lot more sense. I'm going to do these examples out of order. I'm going to do example number 6 first. And example number 6, f of x is equal to 2 plus 4x squared. Now, this is another one that you could expand it, and then you could take the derivative of each piece. This isn't hard to expand, and this might be a good one to expand, take the derivative of each piece, and then do it again using the chain rule to make sure that you understand that it works. So you use the chain rule when you have some kind of a polynomial function raised to an exponent and you're finding the first derivative. So the way you do this is you take the derivative of the entire function and then you multiply it by the derivative of what's inside the parentheses. So the coefficient in front of here is a 1. When I use the chain rule to find the first derivative, if I say I'm taking the derivative of the whole function, here's a 1 outside of here, I'm going to multiply this 2 times this 1, the coefficient becomes a 2, and I'm going to bring that exponent down by 1. Say it's your shortcut first derivative, exponent times the coefficient becomes your new coefficient, subtract 1 from your exponent, but the base of this is 2 plus 4x. So that is the derivative of the whole thing, and then we have to multiply this by the derivative of what's inside the parentheses. The derivative of this constant 2 is a 0, the derivative of 4x is 4. So the first derivative using the chain rule, 2 times 4 is 8, times 2 plus 4x. Distribute the 8, the first derivative is equal to 16 plus 32x. Now, again, that one would have been really easy for you just to expand that using FOIL and then take the derivative of each piece. But let's look at example number 7 next. Again, I'm not going in order. Example number 7, your original function is y is equal to x squared plus 3x raised to the 4th power. Now you could write that out 4 times, multiply, FOIL, and then distribute. You could use binomial expansion, or the easiest way to find the first derivative is to use the chain rule. So y prime is equal to the derivative of the whole function. So I'm going to take this 4, multiply it by the coefficient of 1, the coefficient becomes a 4, I'm going to bring my exponent down by 1. So this, keep what's in the parentheses the same, that's the base of that exponent. So this step right here is the derivative of the whole thing, and now I have to multiply that by the derivative of what's inside the parentheses. The derivative of x squared plus 3x is 2x plus 3. I have one more step that I have to do. I'm going to reorder this so you understand what I'm doing. I'm going to use the commutative property. I have a 4, I have times 2x plus 3, and then I have x squared plus 3x cubed. I'm just going to distribute the 4 to these two things. So my first derivative is, and you have to keep this in parentheses because once you distribute that 4, this whole binomial would get multiplied by this binomial cubed. So it'll be 8x plus 12 times x squared plus 3x cubed. And you can leave your answer just like that. All right, then the last example, again, going out of order, is going to be example number 5. And this function, y is equal to 3x squared minus 5x raised to the 1/2 power. And I'm going to take the first derivative of this function using the chain rule. All right, so the first thing I'm going to do is take the derivative of the whole thing. So my first derivative, dy dx, when I do the derivative of the whole thing, this 1/2 times the coefficient of 1 that's in front of this will give me a coefficient of 1/2. And when I subtract 1 from the 1/2, my exponent will become a negative 1/2. So this part so far is the derivative of the whole thing. And then I have to multiply that by the derivative of what's inside the parentheses. So the derivative of 3x squared minus 5x is 6x minus 5. Now I've got to clean it up. I'm going to use the commutative property like I did in the last example. Reorder, so I have 1/2 times 6x minus 5 times the 3x squared minus 5x raised to the negative 1/2 power. Distribute the 1/2. So my first derivative, dy dx, is equal to 3x minus 5/2. And this piece of it, because it has a negative exponent, is going to end up in the denominator, 3x squared minus 5x, with a positive exponent. So, let me make sure you understand this step. I took the 1/2, I distributed it to the 6x minus 5, so I get 3x minus 5/2. Because this piece of it is getting raised to a negative exponent, that part goes in the denominator, the exponent becomes positive. Remember that anything to the 1/2 power is the square root, so my first derivative, dy dx, is equal to 3x minus 5/2 divided by the square root of 3x squared minus 5x. Almost done. You can't keep that radical in the denominator. You can't have a square root in the denominator. So rationalize the denominator. You're going to multiply this by the square root of 3x squared minus 5x divided by the square root of 3x squared minus 5x. So the first derivative, dy dx, is equal to the binomial 3x minus 5/2 times the square root of 3x squared minus 5x. When you multiply those two radicals together in the denominator, the square root symbol drops out, so the denominator becomes 3x squared minus 5x. And you do have to include in your answer that 3x squared minus 5x cannot equal 0. So this whole thing is your first derivative. Whew, and that's the end of the notes on product rule, quotient rule, and chain rule. I think you're going to understand it. I hope that you understand it. Remember, juniors, you can come back next year for the whole end of the year and have me teach you the conics, limits, and derivatives. I would welcome you back into my classroom. I'm sad that we're not in our classroom right now. I hope you guys are all healthy and staying well, and I will see you again tomorrow when we do derivatives day 4. Take care, everybody.